Hello everyone, my name is Lei Li. I'm happy to present a work that employs the prior information of long axle MRI to assist the segmentation of short axle MRI while information transition. This talk will include 4 parts. We will start from the motivation of this work, then introduce the methodology. In the experiment, we will compare different information transition schemes and analyze the generalization abilities of different unknown pathologies. Finally, we draw the conclusion. As we know, there are different clinical views to visualize the cardiac chambers, such as the short axle and the long axle. However, most current cardiac segmentation studies mainly focus on the algorithms solely using the SA cardiac MRI. One can see that in the SA view, the basal regions of RV tends to be confused with the right atrium. In contrast, LA view can provide relatively clear boundary in the ambiguous regions. With the assistance of LA information, one can classify the SA view as the RV and the non-RV regions. Therefore, the RV segmentation from the LA view can be regarded as a prior information. We construct a joint segmentation framework to employ the prior information. We first adopt LA segmentation and then transform the RV segmentation from the LA views to generate useful prior information. Next, with the prior information, we performed RV segmentation on the SA view. To employ the prior information, we need to align the SA and LA views onto a common space. The transformation parameter between SA and LA views can be extracted from the head information of image. One can see that the transferred LA label only have one straight line traversing the ventricles. In contrast, the transformed SA label covers the whole ventricles, but missing some apical regions. We employ the information to extract the ROI from SA view to exclude the aforementioned non-RV regions, where the SA segmentation tends to be inaccurate. The dataset utilized in this study is from the M&M-2 2021 challenge. The challenge dataset consists of 360 subjects. As the Table 1 shows, there are 2 unknown pathologies during the training stage, which can be used to evaluate the generalization ability of the proposed models. We implemented a baseline scheme and 3 utilization strategies to employ LA information for the segmentation of SA view. Table 2 page presents the results of different strategies on validation set. One can see that though the WO utilization strategy obtained the best DICE score, it performed slightly worse than the joint and pre-utilization scheme in terms of HD. The post-utilization scheme did not present any advantages compared to the baseline, and the joint utilization strategy tended to decrease the DICE score. Therefore, we argue that the pre-utilization scheme is the most reliable and robust among all these strategies. To investigate the generalization ability of our model, we compared the performance on data with different pathologies. One can see that the best performance was obtained on the subjects with the CAM, though the most number of the training data is from normal subjects. It may indicate that the accuracy of each pathology did not solely rely on the number of training data. There are 2 unseen pathologies in the training stage. One can see that only the accuracy of dilated RV had an evident decrease for the segmentation of LA views. It can attribute to the irregular RV shape in the dilated RV patients. However, in general, the model generalization ability on the unseen pathologies is promising. We are compared the performance at the ED and the ES phase. One can see that the performance on the ES phase was statistically worse than that on the ED phase in terms of DICE score, but no significant difference in terms of HD. As we know, DICE score belongs to a volumetric overlap measurement and can be sensible to the size of target volume. Therefore, it could attribute the larger surface of RV in the ED phase compared to that in the ES phase. Now, I'd like to have a quick summary on this work. First of all, our main contribution is to design a framework for the RV segmentation of both SA and LA views. The proposed model introduced an information transition scheme and obtained promising results, even on the unknown pathologies. The limitation of this work is that SA and LA view segmentation are achieved separately, as LA segmentation is regarded as a prior for the SA segmentation. In the future, we will develop more elegant and effective information transition scheme for the simultaneous segmentation of SA and LA views. That's all the content of this talk. Thanks so much for your time. Bye bye.